Hello. Good morning, good afternoon, wherever you are in the world. Welcome to today's webinar. As you've probably guessed, we're going to be going in depth into the 2021 Cloud Report, methodology, how we go about collecting results, how we partner with the clouds. I'm Jessica Edwards. I'm the Director of Content Marketing at Cockroach Labs and a partner and a co-author on the 2021 Cloud Report. A little bit about me. I've been at Cockroach Labs since 2015. I was the first non-engineering hire at the company, and I've been a partner on this report since our inaugural report back in 2018. Joining us today is John Kendall. He's a product manager at CockroachDB. He was one of the lead authors on the report. John, why don't you tell us a little bit about yourself? Where'd you come from? How'd you get to Cockroach Labs?
Sure. Hi, everybody. I'm John, and I've been at Cockroach Labs now for about a year and a half. I joined in summer of 2019, and this is my first year helping out with the Cloud Report starting this past year. And before Cockroach Labs, I was in business school, got my MBA at MIT. And before that, I was a software engineer at Microsoft and Amazon as an application developer. And so it's been quite a journey joining Cockroach on the other side, empowering developers.
That's great. We're glad to have you here. So today we're going to be going in depth into the report. For anyone new, this is a massive, massive undertaking within Cockroach Labs. 2 engineers, Arul Ajmani and Yevgeny Moretsky. I know Yevgeny is actually dialing in. Arul, I'm not sure if he's on the call or not, but if you see him in chat, say hi. So Arul and Yevgeny and John Kendall started working on this report, pulling these benchmarks back in July of 2020. So it took almost 6 months for the entire thing to come together. We published the report in January of 2021. John has prepared a couple of slides for us today. For anyone on the call, this is to get us all on the same page about high-level results, methodology. We won't be on slides for very long, then we'll switch off presentation mode and move into a more casual Q&A. I encourage you to share any questions you might have in the Q&A panel. So John, I'll let you take it away.
Great. So benchmarking AWS, Azure, and GCP. And I'm briefly going to discuss why we do this report, why we take on this huge task of benchmarking the clouds, our methodology, give you a preview of that, as well as highlight some of the highlights from each of the clouds this year. So why do we take on this daunting task of benchmarking the clouds? Benchmarking is hard, and we've taken on that burden for our customers, for our users of CockroachDB. And if you're a user of CockroachDB, you have aspirations of building world-changing applications. And when you're taking on that task, you have that complex decision to make of which cloud and which machine configuration should I use. And the Cloud Report helps developers and users make that decision. And also the greater community finds great value in having this data and in-depth analysis of what some of the trade-offs are and what it looks like for each of the machine configurations that we picked for the clouds. And it also helps us internally as we use this data internally for our analysis. And our methodology, it's a collaborative process, actually, where we started with a series of meetings with each of the cloud providers to figure out things like which machine configurations that we'd use for each of the clouds, our benchmarking framework. And then actually we got feedback from the clouds at as we finished our analysis and talked with them throughout the process. It was a collaborative process, and the clouds were really great partners with us. And the Cloud Report has evolved. Benchmarking is an iterative process. We're not married to any benchmark. And in this year's report, we have a new set of micro benchmarks, and I'm happy to talk about that in depth later in the Q&A. And as a preview for what happened in this year's report, GCP won, but it's not that cut and dry. And some of the highlights that we'll discuss, I'm going to give an alphabetical order and discuss some of the things that stood out from each of the clouds, because there's really a case to be made for using each of the clouds depending on your use case and your workload. So first, looking at AWS, they proved to be the most cost-efficient cloud provider. Cost matters in business, and especially at scale. And they proved to have the most cost-efficient machine in terms of price per TPM, which is industry standard benchmark for measuring cost efficiency in turn for OLTP workloads. In addition, AWS stood out in being having the best network latency of all the cloud providers. Second, looking at Azure, their Ultra Disk really stood out. And when you look at all of their top performing machines across all the micro benchmarks and TPM, Azure's Ultra Disk is the more advanced network attached storage option. They have premium disks, but the Ultra Disks are more advanced. And it proved to be best performing as well as most cost efficient, actually, when you look at price per TPM. And that's unlike what actually happened with AWS with their GP2 and more advanced IO2. Also, they really were strong in storage IO benchmarks, outperforming AWS in most of those, and actually outperforming GCP in some of those. And overall, Azure arguably surpassed AWS for the first time in this year's report. And to wrap up, GCP really stood out in throughput at all levels, network, storage, TPM. And when you look at the network throughput, it's impressive in how even GCP's least performing network throughput machine outperformed all of AWS and Azure's network throughput machines. And then you look at their best one, it was 3 times the amount of network throughput among AWS's best performing. Overall, GCP had the best performance in the report when you look at the aggregate view of all the micro benchmarks. And as I said before, there's a case to be made for each of the cloud providers depending on your use case and your workload. And so I'm happy to discuss more about any of those things.
That's great. Thank you. Can you stop sharing screen, John?
Yeah.
This way we'll get your face a little bigger. So thanks so much for sharing the sort of quick background, top level findings of that report. Why don't you dig in a little bit to a brief history on the report? Where did this idea come from to benchmark the clouds?
Yeah, it's really interesting. It goes back actually to when the team internally was benchmarking the clouds when testing with the 2.1 version of Cockroach in 2018. And they found a material difference when they were just looking at AWS and GCP between the clouds. And they wanted to look deeper, and they looked at micro benchmarks and ended up sharing their analysis with the community, and it drew significant interest. So it's become a routine where we're constantly looking at that, and we're now in our 3rd year of the report, where we have taken it to an whole other level and have the most reliable data yet. And so it's now the 3rd year, and we'll continue to do that.
Nice. How do you choose which clouds to include on this? Why Amazon, Azure, and Google? There were some questions online when the report was published. Why these 3?
And it goes back to why these 3 goes back to helping our developers and making world-changing applications, and they want to use these clouds. These are the most popular clouds among our customers, AWS, Azure, and GCP. And so we actually introduced Azure for the first time in the previous year's report. And we're looking to provide data to enable customers to make their machine configuration decisions among these clouds, because that's what they want.
What does that take when you added Azure last year? So the 2020 report, what does it take to add a new cloud into this benchmarking suite?
It's a significant investment. And Arul and Evgeny Engineering, they did a fantastic job continuing to build what we call our Roche prod infrastructure, which is open source. And we use internally for provisioning machines for testing. And when you look at the clouds, and I was in the trenches looking at it, each of the clouds provide very different interfaces and very different experiences for managing their experiences. And so it's not just a copy-paste operation. It's significant engineering that had to be done to incorporate Azure into our infrastructure, be able to test it across our new set of benchmarks and TPM. So no small investment, had to do significant engineering to make it happen for Azure.
Yeah, that's fair. It's not small. I know even on the Cockroach Cloud side, it's been no small feat to work on Azure. So Cockroach Labs, founded by ex-Googlers, one could naturally think that maybe the report is biased towards Google Cloud. How can readers trust the validity of this?
And readers should question the validity and should be skeptical of any data they look at when they're making decisions for their applications, decisions for what machines they should be using. So they should question. And the reason they can trust it is based on how our business works and how our product works and how we're incentivized to be unbiased and we physically have no stake in it. And I'm an ex-Amazonian, I'm an ex-Microsoft employee, but I'm incentivized to support Cockroach across these clouds because we're a cloud neutral product. And that's one of the parts that differentiates us and is part of our value prop. So it's built into the nature of our business of the product. And so you can trust the data because of that. And also we're open about our steps for benchmarking and just in the nature of how we went about making our test methodology. We worked with each of the cloud providers in a series of meetings. It was several engineers and different members of the product team were involved in reviewing our machine configurations they use, the benchmarks we use. They gave some great feedback on all that. And then ultimately, they bought in and signed off on our test methodology. And then before we even released the report, we shared the results with each of the clouds. And they actually gave some minor feedback to make sure that it was accurate, but we sought to make sure we represented the clouds as best as possible to help our customers. And they were involved with the process. So there's some great credibility that comes with this report, and it can be valuable for anyone that is looking at these clouds for their OLTP workloads.
Yeah, and you touched on this a little bit in your slides that the actual micro benchmarks that were run this year, 3 out of 4 of those changed from 2020 to 2021. What was that process like, selecting those benchmarks with Amazon, Azure, and Google's input?
It's an iterative process. And it started with when you looked at last year's report and the previous year's report, how we used across. So just overall, we look at CPU, we look at network, we look at storage IO, and then TPM. And overhauled each of those micro benchmarks. So first was CPU in previous years. And we proposed our micro benchmarks, and they gave us feedback on what we should use. So just going one by one, first looking at CPU. Previous years, we used StressNG. Very popular tool, great tool for stress testing. And if you talk to anyone on our engineering team on this, they'll talk about how the clouds also pointed out that StressNG is great for stress testing, but if you look at the docs, it's not designed for benchmarking. And it stresses things such as recursion. It's not best practice with applications, so it's not representative of what we're trying to look for at CPU performance. So instead, we evolved and picked a benchmark based on what we decided what was important to measure. And we picked CoreMark, which was a very popular tool and allowed us to have more representative look at CPU. So second, when we looked at network, previous years we used iPerf and ping for throughput and latency and network benchmarking. And the problem with iPerf was there was actually no issue at the time that Azure pointed out. And ping, an older tool that uses an old protocol called ICMP that isn't optimized by the clouds anymore. It's a bit old, so it's really only useful right now to check if a machine is up, something that people use, but not to be relied upon for measuring network latency. So to improve, we picked a tool based on what we wanted to measure, network, and we picked NetPerf that allowed us to have a much better and much more reliable data in terms of network. And lastly, when we looked at the micro benchmarks of storage IO, in previous years, we looked at Sysbench, which is great for getting a comprehensive view of file system performance, but we wanted to do better and really isolate the performance of the disks. And engineering, again, your role did a great job of taking FIO, which was actually written by a developer of the Linux driver, so he knows what he's talking about. And if you look at the docs, it's pretty overwhelming for FIO. The amount of knobs that you can turn to tune it, it's a lot. And engineering did a great job of enabling, fine-tuning it to a nice set of benchmarks we looked at. So we looked at read, writes, because those are different with the storage layer. And we looked at IOPS, throughput and latency for storage. And we were able to fine-tune that with the FIO2, which was super powerful and was able to be much more directly isolating and looking at the disk performance. And we look forward to using that for some time now, and allowed us to get more reliable numbers and overall give us a more predictive view of what would ultimately happen in the TPM overall application level benchmark. And so we're not married to any of these tools, but in collaboration with the cloud providers, they bought in on each of these tools and proposed some of them, and they actually use them themselves for their own testings, things like Cormark. I know that all of them use that. And we're able to give the most reliable data yet. And in future years, these will change. And that's part of the process because things change in a matter of months.
Right. And that actually brings it up. This is a nice segue into a couple of questions we've gotten in chat about selecting machines. There's a question in here, how do you select the hardware that you're selecting? Are you choosing the best available? And then can you talk a little bit about Azure UltraDisk, which really gets into that best available price? What would be an analogous machine with Google? So yeah, talk a little about how you chose the hardware and what does it mean to choose sort of premium disk. I actually think premium disk is what one of the clouds uses as their nomenclature, but the advanced disks, I think we called them in the report.
So yeah, I'll talk about how we chose the machines and that collaborative process that we went about with each of the clouds. And the way each of the cloud providers package them is very different. And to put it in super simple terms, it's kind of a spectrum of where AWS is very prescriptive about which machines that you can use. They're memory optimized, they're storage optimized, they're compute optimized, and it's very specific in how they segment that. And on the other end, GCP is very flexible, and it actually requires some expertise to really be able to fine tune to get the most out of it. But if you know what you're doing, you can get a lot. And Azure is somewhat in the middle, where they have some flexibility, and they also package things in a way that's directly tied to what you're trying to offer. And given these very different experiences and also very different experiences in how they price it and the packaging, it was an exercise of making sure that we had a set of machines that were worthy of being used and experienced to compare performance. So it resulted in having a lot more machine configurations with Azure because of simply how they structure things. We took those factors into play to make sure that it was a fair bench set of experiments, and times that it was perhaps potentially unfair, we call that out in the report. But ultimately, at the end of the day, we're trying to make fair experiments to help developers here, and we use those. And so that was ultimately the point of the exercise of making the choice with the machine configurations. And it's an art, not a science.
It's truly an art, not a science. One of the funny things in putting that report together too, and this is a different side of how the sausage is made, is when we're working on the data viz of how many machine configurations options there were with Amazon versus Google. And if anyone's looking at the report, you'll see we started to group AWS machine configurations together because we had something like 26 bars compared to 6 or 8 bars at Google. And it just was getting really tricky as a data viz challenge. And in looking at the data, we started seeing patterns of sort of natural machine grouping. So you'll see some of those places where we grouped clusters of machines together, types of machines together in that report. There's a couple of questions in here around network latency, network throughput, and I know that network was one of the, I'd say probably trickier spots of the report. So do you want to talk a little bit about latency, throughput across the clouds, and how you went about benchmarking and verifying that data?
Yeah, network latency and that network benchmarking is critically important, especially given the CockroachDB is a distributed SQL database. We're consistently replicating data across machines in that distributed pattern, so it matters to minimize that. And when you're making your application, your world-changing application with Cockroach, you often have to think about the trade-off between minimizing network latency and maximizing availability. And that means, do you cluster your machines or you spread them out to maximize availability? And that's something that we wrestled with and we talk about in the report. And so for this year's report, to make it as fair and consistent as possible, we didn't apply what AWS calls placement groups, Azure calls placement proximity groups, and I believe GCP calls it placement policies. Anyway, they have their own definition of applying these rules when establishing how to get best performance across the network. And what we did was to make it as equitable as possible is we used everything in US East. We kept machines within a single availability zone and measured based on those default configurations. And that's what we did that resulted in the data. And it can result in some variance depending on where the machines are placed, whether they're on the same rack, or they're on racks next to each other. These data centers are the lengths of multiple football fields, and it matters where they ultimately place them. And so it's a tricky problem to solve, and we'll continue to build on that in future reports. It's possible that we do apply some placement policies just to see what happens when we have all the clouds say that we have the machines clustered together. But for fairness and for clarity, and we choose the default configuration, and that's how we set up that experiment.
Yeah, and I think that I like that you touched on that, the placement policies, machines on the same rack in the same data center. A follow-up to this question from Sarma is how does it compare in a cloud scenario versus a traditional data center hosting, these network latencies? Can you talk a little bit about that?
How does it compare with the cloud versus self-hosted, or what are we saying?
I'll read the question to you verbatim. So network latency is benchmarked at the end user. Mm-hmm. How does it compare with the latency in a traditional data center hosting? And I don't know if you can speak to this at all.
So I think it depends on what your setup is. And at the end of the day, depending on your deployment, you could be with Cockroach set up in multiple regions across the world, or you could be in a single region, which a lot of users are, and you need to benchmark based on that. And and you also need to be smart about how you apply your patterns when using Cockroach to get the most out of it. So the recommendation at the end of the day to make sure that you're getting the best is to run experiments yourself, and you can follow our patterns for doing that by being cognizant of the tool that you use. We provide a great tool in our open source repo with NetPerf, and being consistent about how you apply it across each of the clouds to make your decision on which cloud to use and which machine configuration to use to make sure that it's being optimized, to make sure that your applications are low latency, because that, every millisecond matters. I mean, I think about when I was at Amazon and the milliseconds, the P99 latency that you're achieving, it goes back to what machines you're using and how you have it set up and how your application is optimizing for that. So the only way that you know is to run it yourself and run the tests.
That's great, thank you. And Yevgeny, who's again one of the engineers on this report, he's slacking me. It looks like some of our Zoom settings are such that I think attendees can't respond to questions. I thought maybe Yevgeny would be able to respond, add more color. He can't, but he can secretly Slack me. And so what Yevgeny says here is Cockroach is a distributed system. At any time, our nodes talk to each other. And this is something that John was discussing, especially about, multi-region setups. Inter-cluster latencies are important. And that's where placement policies really become critical to think about and evaluate. And having said that, Yevgeny says that the latency to the external user will dominate. Yevgeny, if you want to, I'm not sure how to end on that last sentence. So if you want to chat through anything further there, please do. Or John, if you want to elaborate on that.
I mean, I agree with what Yevgeny says here, and it's of critical importance at the end of the day for the user's applications.
That's great. Yeah, thank you. I'm going to just take a quick look through chat, see other questions that have come up. So what are some of the high-level differences between the three clouds and maybe what their specialties would be? What the kind of workloads might be appropriate for one cloud versus another? If you have any thoughts there, the question gets into AI, communication platform, data management.
Mm-hmm. And we focus on the performance of the clouds just for OLTP workloads. And what we saw in the snapshot of data that we looked at was that it depends on the workload, but as I stated earlier, in terms of cost efficiency, AWS stood out. In terms of raw throughput, GCP was best at all layers, and Azure was really strong in the storage benchmarking. At the end of the day, each of the clouds are going to be very performant for your OLTP workloads, and there's going to be a lot of factors that come into play when picking that. So each of the clouds can apply for those cases.
Are there any adoption trends that you've been seeing as product manager at Cockroach between the clouds that makes some verticals perhaps prefer one cloud over another?
Some adoption trends that I've seen. I've seen that, yes, and I've seen Azure grow in popularity among our customers, and there's a lot of factors for that. It's the customers don't make buying decisions purely on performance. It oftentimes has to do with different their existing infrastructure and how they may be already integrated with Azure. In addition, we're seeing growth in our customers using Cockroach Cloud, and how between AWS and GCP that they are, it really depends on what they're trying to do. And really, I've seen growth across all the clouds, and not necessarily tied to specific verticals, as we serve a lot of verticals with CockroachDB.
I'm going to pop back over. Sorry, I'm losing some windows here. I've got too much going on. What were some of the surprises when you were looking at the data?
Yeah, this was very fun to look at. And I think one case that really stood out to me was, I'm going to talk about one machine configuration in particular, and that was GCP's C2 standard machine, which when you look at all of GCP's machines among this large set of storage benchmarks, C2 standard performed the worst consistently compared to other GCP machines. But then when you look at TPM overall, the C2 standard was the best performing machine among all of the clouds. And it was interesting to dive into why is that? And it's because—
sorry, I'm not sure if you've defined TPM. I can't remember if you defined TPM on the call. I'm so accustomed to hearing it that maybe just give a quick refresher. And my apologies if you already defined it on the call and I'm getting our run-throughs mixed up.
So TPM is our derivative of TPCC. And TPCC is an industry standard benchmark for measuring OLTP performance. And CockroachDB is an OLTP database. That's a distributed SQL relational database. And so looking at performance of the overall application performance for workloads like Cockroach, that's what TPM represents. Application performance for workloads like Cockroach. And the C2 standard machine was the top performing machine across all machines across all the clouds in this report. Yet it performed worse on the storage IO benchmarks for all of GCP machines. And what stood out to me in that particular case was that how we measured OLTP performance with TPM, it turns out that it's a very compute and memory intensive workload. C2 standard is a compute optimized machine. And because of that, we realized that the way this workload works and how we've done it is that it wasn't ultimately underutilized some of the advanced disk options, and didn't push the storage layer hard enough for that to show the value of that as much. So it skews more as a compute and memory optimized workload. And it was interesting to see that that gap. And depending on your workload, C2 standard might be a good choice. But at the end of the day, we found that to get better OLT performance, you have to look beyond that and consider adding nodes, consider getting more memory and better CPUs to get the best performance. So it's a complicated decision of picking which configuration, but it was crazy to see how C2 varied in performance across the micro benchmarks and ultimately being the top in the TPM benchmark.
Yeah, that is unexpected.
Mm-hmm.
I know that one of the other places we saw something that we weren't expecting to find was looking at CPU processors,
Mm-hmm.
Intel, AMD, Graviton 2. Can you talk a little bit about that?
Yeah, so when you look at CPU performance, we looked at it on a single physical core and 16 physical cores using Cormac. And it ended up being representative of how these processors were set up. So Intel and AMD, and the Graviton 2 is AWS's custom built processor and ARM-based processor. And Intel, the way its performance is optimized to work on a single core, while the AMD processors uniquely are designed to perform in burst mode on multiple cores, which is something that explicitly actually Intel doesn't do. So that was interesting to actually see that play out on those benchmarks. AMD working ultimately performed better on multiple cores, and Intel working better on a single core. And after our iterative process of looking at the data and what is supposed to happen and what actually happened, single core is most representative of the ultimate performance that we were looking for. So that was of most relevance. So that was something else that was important to look at. And I'm happy to go in more in depth on actually that process that we went about doing that and running the runs. But yeah, there was a big difference where AMD performed better on multi-core, 16 cores, and Intel was the best on single.
That's great, yeah. And then you have a price estimates in the report on some of the benchmarks. You didn't include price estimates for everything. How'd you go about calculating pricing estimates and why include it?
We took on-demand pricing for our pricing estimates for fairness, looking at both machine and the disk configurations. And that was a particular, the clouds have their own calculators, and we did our own calculator to make sure everything matched. But yeah, we ultimately used on-demand pricing across the clouds. And what was interesting to see was how each of the clouds price things so differently and have different things that they price for. So for example, you have to, when using, I forget if it's either premium disk or ultra disk, you have to explicitly pay for different IOPS and throughput. Well, that's not the case, say on my GCP, and it's more included. And so each of them have very different pricing models. And it was a game of, not a game, but it was a careful balance of making sure that first, the machines were configured in a way that allowed for fair comparison across the clouds. And then when taking those configurations, making sure that they're priced properly. And it was shocking to see, certain machines that are more expensive actually trying to be more cost efficient. For example, with the ultra disk machines on Azure. And yeah, price doesn't necessarily directly correlate with ultimate performance at the application level that the users care about.
That's helpful. So we won't run this webinar for too long. We probably will wrap up in the next 5 minutes or so. So there's a question in the chat about, who is the overall winner? And I'm going to actually pivot that question to, if you were building your next application, which cloud would you use?
It depends. So if I'm a developer and I'm using CockroachDB and I'm looking to build my application, maybe with multi-region aspirations, and it depends on what type of application I'm building. And it also, you have to run tests to be sure on what's happening. And you may have a partnership with Azure that allows you to get a better bang for your buck than, say, another cloud. And So yeah, our customers have varying different workloads. Some are more read heavy than others. Some are only in a single region. It depends on your workload, and each of the clouds, as proven in the cloud report, have strengths in different ways. But something else that needs to be called out is at the end of the day, at the top level application benchmark that we were talking about of TPM, that's representative of OLTP performance, representative of application performance for workloads like Cockroach. All the clouds were very close. It was super close. Even though GCP surpassed, it was they arguably performed roughly the same in that benchmark. So if I'm a developer, I'm also thinking about what tools my team, people that are maybe DBAs, are comfortable with using, and their familiarity with those tools. There's really more variables than one would think, and it's never a straightforward answer of, it would be irresponsible to recommend just one cloud without thinking about the context.
Yeah, and this is really where the sort of key benefit, a core benefit of CockroachDB comes in, is that CockroachDB is cloud agnostic. And I know you mentioned that up front, but it's always worth reminding that you can change your mind. You can deploy CockroachDB on Google and then change your mind. You can get better pricing, better configuration. You're moving to a country that your chosen cloud provider is not in, which can happen as you expand your business. And you can move Cockroach to another cloud. You can run CockroachDB across clouds. You can run multi-cloud. And these are some just important things to remember and are fairly unique to CockroachDB. Is that you can run multi-cloud. It is a cloud agnostic system. So then last question here as we look to the 2022 report, which I'm sorry to say it, we're already in February. July is not so far away. What do you wish you could have included in this report that you couldn't, and you can't include everything? We published in January, reInvent was in December, Amazon announced new machines. What do you wish you could have included that maybe you hope to include in the 2022 report?
Yeah, there's always more things that we could measure, and if you're not careful, your matrix of machine configurations can explode, and it never ends. But there are three things that stick out to me that I expect we'll include in next year's report, that it would have been nice to include it in this year's report, because machine configurations between the time that we started in July to when we ended in January, or at least last month, they were already innovations. So going back to the networking benchmark, I'm super curious to explore those placement policies and see what happens when you cluster the machines across the clouds and compare that performance. So I wish we were able to dive more into that, but as is, we provided some very reliable data to look at performance between two machines in an availability zone. Second, I look at how GCP we only looked at PDSSD as far as the network attached disk, and we looked at two different ones for GCP. I mean, at AWS, we looked at GB2 and IO2, the general purpose and their advanced, and within Azure, we looked at premium and ultra disk, their general purpose and advanced disk. Within GCP, we only looked at PDSSD, and they had extreme PD, but there wasn't a quota available to us to run it on extreme PD, which would have been really interesting to see. And the hope is to explore that next year. And lastly, AWS introduced GP3, which would have been interesting to look at in this year's report, and will be interesting to look at in next year's. And early signs suggest that it may be even more cost efficient. So overall, more interesting, more granular network benchmarking, extreme PD from GCP, and GP3 from AWS would be interesting to see.
Yeah, I'm looking forward to it. It's see what is available to us when we start having these conversations again with the cloud providers. Thank you so much for joining, for giving us this in-depth look at the report, how the sausage is made. If anyone wrote questions in, if you threw them in the Q&A panel and we didn't get to them, we'll be able to respond to you over email. So if you threw them in chat, those disappear when we close out this Zoom. So if you had those and we didn't answer, if we didn't get to your question, or you have any other thoughts, throw them in that Q&A panel, which is right next to the raise hand button in the bottom of the screen. A recording of this will be available. It'll get emailed out to all of you. If you haven't read the report yet, please do. We've got a blog post on it if you are only looking for the too long didn't read version. Thank you again. Thank you everyone for joining. Thank you, John, and I hope everyone has a wonderful rest of the day. All right.